Okay guys, good afternoon. We will be going after example 2.4 from the Fogler's textbook. Before we go to 2.4, we just have to understand the basics behind multi-stage CSTRs and multi-stage PFRs. Okay, so let's say you have one reactor, which is reactor 1. So reactor 1, by using the formula, you will have moles coming in minus moles coming out plus moles generated is equal to the total number of change of the number of moles. Now here you can just write FA1 as FA0 minus FA0 into X1, where that's the moles, the fraction of the moles of component A that's already reacted. So using this you get the equation for V1. Now similarly you can write the next step as F1A minus F12 plus RA2, V2 is equal to 0, and then using the same you will get V2 is equal to FA0 1 minus R2 X2 minus X1. So that's just you have FA1 as that, and FA2 would be FA0 minus FA0 into X2. So using this you can just solve and you can get the volume for V2. So once you know these two factors, then it will be easier to derive the solution to the problem that we are going to do, which is example 2.4. Okay, now going to example 2.4, what we know is that there are two CSTRs with 40% conversion on the first reactor, and on the second stage you have to calculate what is the volume to achieve 80% for the overall entering species, and we have the value for FA0 by minus R. Now let's write the first equation. So what we know is that for x is equal to 0.4, so x is equal to 0.4, FA0 by minus RA is equal to 2.05 meter cube. And we also know from the formula that we had just derived that FA0 minus RA at RA1 at x1 into x1 is equal to, by substituting this, you have FA0 by R as 2.05 and x you know is 0.4. We'll get the value as around 0.82 meter cube. So that's how we solve for V1. Now using V2, you can use a similar formula. V2 is equal to FA0 minus RA2 into X2 minus X1, which we have just seen from the initial derivation. In substituting this, you will get FA0 by R2 for x is equal to 0.8 as 8. So you just substitute that 8, become 0.8 minus 0.4, and solving this you will get 3.2 meter cube. Now another way of doing this would be if you can just plot FA0 by minus RA with respect to x, and you get the point for 0.4 and 0.8. So this would be your volume for your first CSTR, and then your second CSTR volume would be this one. Sorry about that, just erase this part. Yeah. You can just shade with another color. So this is the volume for your first CSTR, and this is the volume for your second CSTR. Now what would happen if instead of doing it two stage, if you want to do it as one stage, then if you combine these two volumes, it's just 3.2 plus 2.05, so it's around 10 meter cube. So that would be your total required volume. Now if I was going to do it as a combined volume, then what would be required is we can just calculate the same one and then see how much it would be fit for the combined one. Let's using the same formula. If I go V1, and over here at 8 but 80%, and the value is 8, So 8 into 0.8, so that would be the case for if it's just one stage. It's 6.4 meter cube. If I draw the same thing, that would be 0 minus RA by X. So plot, here's your 0.8, here's your 8, and this area would be that size if you are going to do for 1 CSTR. So in this, just one point before we go to, I think it wasn't 2 meter cube plus 3.2, it was 3.2 plus 0.8. So in this case it would be V total would be V is equal to V1 plus V2. V1, which we have derived initially, is 82 and V2 is 3.2. So when you add these two, you will be getting around 4.02, which compared to 6.4 is much lesser. So for CSTR, it's always better to do in stages so that you can reduce the overall volume. So this is in case of comparing volumes for CSTRs in series, and in the next video we can explore for PFRs. Thank you.